Welcome back everybody to the channel. I got an interesting one for you today. We're going to make a concept DX commander. You might have seen the first episode a couple years ago where I did the Lieutenant Dude. Well, you might as well call this the Lieutenant Dude. We're going to take a carbon fiber mast. We're going to make a DX commander, but I'm going to try to make this simple. With this 25-foot carbon fiber mast, we're going to shoot today for 4 bands, 40 meters, 15 meters, 20 meters, and 10 meters. But really, let's just see what we could do with this carbon fiber mast, keeping things as easy as possible. Hopefully. In order to keep this antenna kind of unique and quick, I have a series of toppers for my carbon fiber mast. I've already shown them off in prior episodes, but there is this one, which would be perfect for 2 or 3 bands, you know, for example, 40 meters, and on this side, maybe 20 meters. But because we're trying to do 4 bands today off of 3 antenna wires, much like the DX Commander Expedition, we're going to be using this little guy that I designed. Now, the nice thing about this topper as opposed to this one is, this one I needed a lot of strength for because this one was going to be used possibly to guide things down. This is going to be solely just for holding wires with a little bit of force from bungees. I'll show you that in just a few moments. But I think that PETG will be fine for this. If you notice it's a little bit bent, that's nothing to do with the sun. That's more the printing, and I didn't have my bed well, so I got a little bit of warp on the print. But I think it'll be fine for today's purposes. Now you are gonna notice on here I have a 3/8 inch connector bolted onto the bottom, and then on top of here I just have a little bit of a adapter so I can go 3/8 to M10. What we're gonna do is we're gonna put this on the topper, and then in just a little bit, we're gonna put on this little short telescoping antenna. And I guess in theory, not only could you put this on here and extend, because this is a 25-foot mast, you could extend this out so that you could tune 40, but then you could also retract this or just remove it so that you could have 10 meters as well, 30 meters as well. In order to keep things simple, we're gonna have there's no wind today or anything, we're just gonna have one area where we're gonna guy in our mast. I'll be right back, you don't need to watch this. Some of this might sound like a repeat, because it probably is. What I'm doing here is I'm just gonna put this antenna in, and then connected to the bottom portion of this plate where that 3/8 inch bolt is, I'm gonna go ahead and I'm gonna place a 25-foot antenna wire there. That's going to allow me to have 25 feet plus whatever extension this is. I do have some DX10 wire from the DX Commander. I had extra left over after I built my last one, but instead of using this awesome wire today, which I will use eventually in the future, I'm gonna use this telephone wire that I talked about in my last episode, because, well, it's kind of already all been cut and there's no reason to waste it. For the radial wires, I'm going to be using my DX Engineering antenna wire because, again, I've already made those a couple of years ago and I'm going to reuse them. I'll show you in a minute how I'm attaching the radials to the bottom plate. But first, I'm going to get the rest of that set up. Before I hoist that in the air though, I do want to also show you what I'm using today for a plate on the bottom of the mast. And actually it's not going to attach to the mast. Although the mast does have a section where I could unscrew it and make a plate, I just haven't done that yet. Instead, I'm going to go back to this concept, or a couple of different concepts that I've shown to you in past episodes. Again, I'll link them below. The tent spike that uses a trucker mount to go into the ground, connected with the 90-degree SL239 connector. And then on the top, I made this for the Hamstick Commander. I'm gonna put this into the ground. And what I'm gonna do is I'm gonna attach my antenna wires here, here, and here, and I'll have an extra spot left over, but then my radials will go on the bottom portion here. My first element that I'm gonna make is gonna go to that antenna. It's gonna be the 40-meter element. I'm gonna be using DX10 wire from the DX Commander, and all I'm gonna do is basically strip it with these Quinn wire strippers. They work great, to be fair, and then I'm going to crimp on one of these larger ring connectors. It's gonna fit fine under a 3/8 connector and not slip out, as you can see. As a result of using a lock washer on the bottom portion of this new plate that I made, you're going to notice that the antenna has a little bit of a bend to it because the lock washer is not allowing that bolt to be straight. I could fix that later, no big deal. But what I'm doing now is I want to check for continuity from the antenna to the wire. Actually, to the bottom of the wire would probably be the best. We're good to go. For this plate, I'm going to simply put it right alongside the carbon fiber mast, and my whole goal on this is that I could have one element of wire going here, one here, and then one over here. Yes, it is close to the carbon fiber mast. I think I have a way to possibly resolve that, but we'll have to see as the day goes on. What I'll do now is I'm going to hook up this first wire, the 40-meter element, and I could use fork connectors right here. I understand I could. It's just these are what I had available at the moment. The Sony camera keeps overheating. It's like 78 degrees out. I got that element on, so next thing I want to do is I'm going to get some bungee wire, and I'm going to tie some bungee wire on each of those other two elements at the top. Connecting the bungee wire to the actual antenna wire is going to be this little bit of a tensioner, which I showed off in the last episode, and then on the top here I have each wire color coded based upon what band it is. So for example, 20 meters. Hot tip, you could do that with your coax as well. Just for fun, I am actually going to use this telephone military industrial strength cable wire for the 20 meter and the 10 meter element, just because I've already had it made also. And this one is a little short. This must be for 17 meters now that I think about it. And here's a better example of the plate. Now typically I do use this ring and I put it down into here, but today I figured I'd try something new on that 40-meter element. I think it would be better down here. Bungee cord for 20, bungee cord for 10, and this is the joy of it. Now watch, there's going to be no other kind of plates or support that's going to be in between. At the bottom here, we just have each of these, the 40, the 10, and the 20. But there's going to be no plates in there because of these bungees, and because this is a collapsible, clampable mast. These clamps are probably going to do the job in conjunction with these bungees that we want to keep the wires nice and tight. As I bring up these masts, well, one thing I got to be careful of is the trees above me, which I'm okay with. I'm just going to clamp each one of them into place, and as I get toward 25 feet, the size of this mast, we're going to notice that these bungees will get tight. And that's the thing about it, is even if it gets too tight before 25 feet, we could just extend the telescoping antenna just a little bit, right? Now with that, I do want to actually take my 10-meter element and I want to put it on this side of the wire. But one of the things I was thinking about for separation on these actual wires is these tensioners right here, and I can kind of click them into place, and that gives us a little bit more distance with the mast if we need to. But let's see how it will work after I get this wire over to this side. For my radials today, I am using a lot more radials than even last week when I was testing the 40-meter element. I'm using 1, 2, 3, 4 bunches of 5 at 10 feet each. So, see, 50, boy, I don't math, 200 feet of radial wires. And I just did this in order to connect them all, right? I have a bolt going through and connecting to all of them with those same ring connectors, and then I have a power pole connector up here. So I'm gonna get those hooked up, and then we'll check it on the standing wave ratio, the analyzer, and see what's going on. This is what it looks like on the ground, and this is the power pole connectors. There's no reason to go red and black, I just did it. But I will say I'm using the knockoff ones as far as I recall, so I could just rapidly disconnect if somebody were to trip on there. And that is the joy of having these fake power pole adapters, is they disconnect pretty easy. One thing I did not do yet was check to see if there's continuity between, of course, the antenna portion of this L bracket and the radial portion, because we don't want that. And that will definitely throw off results. Just to confirm here, I have one port in the, or one probe in the antenna port. Continuity, no continuity, no continuity, that's good. Now on the outside, no continuity, continuity, continuity. We're good. I want to show you, remember the other day I wasn't able to quite get 50 ohms with the 40 meter next to the carbon fiber, and two things attribute to me getting 50 ohms, or roughly around 50 ohms. Number one, I got that 40 meter antenna a little bit away from the carbon fiber mast like I just showed you a moment ago. But number two, I went ahead and I added more radials, and both of those things helped drop my impedance values. I haven't really looked at this too much yet, so let's just take a look. We're right at 54 ohms. In my opinion, that's considerably better. I will tell you I'm running RG8X coax, and unfortunately today I didn't bring my bellin or my choke, so I don't have a choke in line. That was my impedance values, and it looked pretty good across 40 meters. What about, oh yeah, 1.2 to 1, 1.1 to 1.10, 1. Yeah. Okay, so my lowest standing wave ratio, I know, it's not all about standing wave ratio, is at 7.138. And that impedance right there should show me 54 ohms. But what about our X value? And we want X to be as close to 0 as possible. We're at 1.6. Aha, look at that. We're actually at X equals 0 right at about 7.123. And that's right where I wanted to be, because, happy coincidence, we might get 15 meters as well. This, by the way, isn't a build video. If you want to see the full build of a Lieutenant Dude or a DX Commander, check out that video I have as well. But let's just start now at 21 megahertz and go to 21.6, okay? A little bit bigger, larger. And 1.6, 1.5, 1.5, oh, 1.4, 1.3. Okay, that would mean I could probably lengthen my Lieutenant Do, or Lieutenant Do, the Carbon Commander, whatever you want to call it. I could probably do that. 20 will definitely need some adjusting and help. I did separate it a little bit further from the antenna, but I might have to separate it at the base plate a little bit more as well. I'm at 1.76 to 1 standing wave ratio at 14.539, so technically I should lengthen it, but I could still hit parts of the band at 1.8 to 1. And I think I'm going to be okay there, except we do have a little bit of an issue. If we look at our impedance, we're going to notice it's way low. It's actually high, 87 ohms. And I probably could fix that. But let's just check the X value though. Negative 8.7, not as bad as I thought it could be. We don't really see a positive, let's see, 27. There we go. We're at 0 at 13.777. And our impedance there is probably 120 ohms. So as I mentioned, 20 meters kind of seems off, but we're going to still try to use it and see what happens. It's probably not going to be as efficient. Let's check our standing wave ratio at, I don't know, the 10 meter band. And to do that, I'm going to go 27 megahertz to 30 megahertz. I know. Phenomenal. 1.1 to 1 at 28,357. That's kind of right where I was shooting for, 28,385. And we're at 47 ohms. And then our X value, negative 4.2. We're at 0, roughly at 28.452. And our impedance there. This camera keeps overheating, but I also wanted just to take a look here. I did fix 20 a little bit. I got it down to like 75 ohms and like 1.6 to 1 standing wave ratio. So it's not completely fixed, but here we are on 6 meters. Let's just take a look at the impedance values and the X values and see if 6 is going to be good too. Yeah, we're at like 92 ohms. We get down to 72 ohms and there we are at 50 ohms. We're at about 50.380. And let's take a look there at our X value. It's probably through the roof. 37.3. 6 meters was a complete afterthought. But let's plug in a radio and see if we can't make contacts, you know. And this is kind of, okay, I just wanted to show you how I kind of fixed 20. I separated it a little bit from the actual plate that I built. And I think that just a little bit more separation helped lower that standing wave ratio and those impedance values just a little bit. I guess maybe the theory is when I build the plate for the mast, I have longer arms, so we get further away from that carbon fiber. But that's what we got going on. You've already seen the radials, how they're working. And then, I don't know what you want to call this, Christmas tree formation, or, you know, basically kind of like an off-center diamond.
CQ, parks on the air, CQ, parks on the air. This is Whiskey Niner, Foxtrot, 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 W9, FFF from Park Kilo 1012. Whiskey 1, Golf, uniform, uniform. And I have you 5x6 out here in Western Kilo Sierra. Appreciate you being out there today. Kilo 124, Alpha Delta 4, Juliet X-ray. QSL, I have you 5-4 Golf Alpha. Thank you for the activation.
Thanks for the 5-4 in Georgia. Have a great day, sir. It's Whiskey 9, Fox, Fox, Fox for Parks on the Air, QRZ.
Kilo 124, Sierra X-ray Hotel. 5-5 here in National Console. Thanks for the activation.
November 5, Victor Alpha Whiskey. Is that QSL?
Victor Mexico November. November 5, Victor Mexico November.
All right, roger that. Thanks. November 5, Victor Mexico November. I have you at a 5x4 at 54 in the Park Kilo 1012. QSL?
Roger, 5-5 in Arkansas.
Yeah, thanks for your patience and thanks for that 5-5 in Arkansas. Have a great day, sir.
CQ, parks on the air. CQ, parks on the air. This is Whiskey Niner, Foxtrot, 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 W9, FFF from Park Kilo 1012. CQ, parks on the air. CQ, parks on the air. This is Whiskey Niner, Foxtrot, 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 W9, FFF from Park Kilo 1012.
You got a park to park?
Kilo India 5, Delta Victor X-ray, you're 5-5, 55 into Park Kilo 2790. Oscar Charlie.
A 4x4, 44 in a Park Kilo 1012. QSL? RZ.
Kilo 7, Sierra Echo November.
There you go. Kilo 7, Sierra Echo November, a 5x9, 59 in a Park Kilo 1012.
Good morning.
Yeah, 10 was dead. I already checked it. 40, I made a couple of contacts. Actually, Arkansas, which was pretty interesting. Very low, weak signals, but I think that's more indicative of the band. We're going to turn on Whisper in a minute and see how Whisper does. But first, I want to do 15 meters, sorry. You want to see a magic trick?
CQ, parks on the air. CQ, parks on the air. This is Whiskey Niner, Foxtrot, Foxtrot, Fox.
Park Kilo 1012. QSL?
QSL 5757 in Texas. Thank you for your activation. I got you on 20 just a few minutes ago. Good luck.
I appreciate that, and you might even get me on 30 in a little bit, but thanks a lot, and I hope you have a great day if we don't talk again. 73 to you, Kilo Lima 7 uniform from Whiskey Niner, Foxtrot, Foxtrot, Foxtrot. Have a good one, and QRZ. This was the best button I've ever installed.
CQ, parks on the air. CQ, parks on the air. This is Whiskey Niner, Foxtrot, Foxtrot, Fox.
For my next trick, because anybody can make contacts, right? We just still don't know how efficient the antenna is or if it's really working that great at all. And we still won't really know. I'd like to have the control of a quarter wave 20 meter antenna, but I didn't bring the long vertical antennas. Plus, I would also need another ground spike and put it in, you know, somewhere far away so the antennas don't interact. In the meantime, though, we are using this Zactec Whisper transmitter, which you see right here. And I don't even remember what bands it's transmitting on, to be honest with you. I think I have them all selected. So we're going to get to see what all the bands look like here. And with that, I have 40 feet of RG58A wire SMA to SO239, which goes into the antenna. And if you notice, I'm kind of under the truck here because it's getting really kind of warm and everything's starting to overheat. I turned off the FT891 because it's overheating. 1, 2, bad news, bad news. The bad news is I was using my Whisper transmitter. I had it under the truck for shade, and it stopped transmitting around 20 meters, and I couldn't figure out why. But I just brought it into the vehicle and I tried multiple power outlets. I thought maybe this little solar battery died. Long story short, my Zactec Whisper transmitter is dead, so I'm not going to be able to get any of those statistics. Such as luck, we got to roll with it. So what are we going to do? Let's call WQ9F over here and see if he's got any kind of special antennas that he wants to try to go side by side with, and we can maybe compare the signal strengths and so forth. And just an update for you, after hydrating, the Whisper transmitter is now working again. Wow, watch this. Whiskey, Niner, Foxtrot, 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 QSL. $15 is up and down, but that was pretty cool. I ended up with a contact to, I gotta fix the frequency, but I ended up with a contact to Barbados, 8 Papa 9 Charlie Bravo. And it was up and down like I mentioned, but 15 meters on the Carbon Commander, the Lieutenant Duece. Lieutenant Duece. Oh, whatever. But that was kind of cool. My Whisper transmitter did it again where it shut down, but Kevin, WQ9F, had been coming out this way to activate the parks anyway. And he stopped by with his ICOM and with his laptop, and he activated the park on 40 meters, 20 meters, and 15 meters. And he was being heard. Of course, 40 at this time of day, where by now it's about noon or 1, I don't know. And he was being heard kind of like on the East Coast, and then here in the central part, like nearby, right? 40 meters. I'll leave on the map a little picture of what I'm talking about. 20 meters, he was heard a little bit more, and then at the current moment while he was operating, 21 megahertz was the maximum usable frequency. And that's where Kevin was really making some good contacts. He made China, he got contact with China on FT8, and he got contact with Russia on FT8, and he was hearing stations all around the world, from Europe to, again, Asia and so forth. So it works. The Carbon Commander has a couple of things that maybe I'll be able to fix, maybe not. But the 40 meter element, the 20 meter element, and the 10 meter element, I have them spread out a good ways. I just can't get 20 meters under 1.79 to 1 when it's having the 40 meter element on here. If I take the 40 meter element off, it works. But the concept is really cool, this whole thing. I like the concept of the Carbon Commander, the Lieutenant Duece, because I like Lieutenant Duece. I think that's a hilarious name. But we have a couple of things here that would make this really interesting for Cal, okay? The DX Commander. If you guys don't know, DX Commanders are now sold at DX Engineering. And if you also don't know, DX Engineering has their own line of both carbon fiber and fiberglass masts. So if carbon fiber, like the Giga Dude here on sale at shop.hamradiodude.com, didn't work out for you, or you don't want carbon fiber, you could always go pick up a fiberglass mast over there from DX Engineering. But more importantly, what if the DX Commander teamed with the Lieutenant Dude and DX Engineering and did something like this? You know, so maybe we sell this topper here for their masts. Something along those lines. You'll notice that this is crooked, and it's no indication of the actual 3D printed part as much it is that lock washer I mentioned earlier on the bottom of the topper here. Look at how quick this comes down. Let's say you needed to make an adjustment. You can cut this, do whatever you got to do, and then rapidly deploy it back in the air. When the antenna is deployed in the air, or the whole mast and the setup is deployed in the air, because the 20 meter and the 10 meter use these bungee elements, that means with the bungees being attached, or excuse me, with the antenna wire being attached slightly to the guy support ropes, that we basically get this antenna wire away from the carbon fiber altogether, because the bungee is what's going to be next to the carbon fiber up here, and it's going to go down in a slant formation if we have the antenna wire on clipped onto here or just tied onto here. And I like that concept. But also I didn't need anything other than these 3 guy supports. It's not very windy today. And realistically, then all we need to do is either create a plate for this or just use the whole tent spike mast thing that we've done in the past. This is actually kind of really clean, to be fair. Take this off right here, pop it off. And then if I take my wires off of the bottom plate, all I have to do is maybe get a couple wire winders and neatly wrap this together. Is it perfect? No. Is it a cool concept? You know, that's subjective. I think it's cool. But regardless, I'm just about out of water, and I'm gonna pack this up so I can go get more. Until then, hydrate. Like, comment, and subscribe.